Hello viewers, welcome back to my tutorial, and in this video you have an exact differential equation problem here. So you have e to the power 4x plus 2xy squared dx plus cos x plus 2x squared y dy equals 0. So as we have talked about in my previous videos, exact differential equation is always in the form where we have the partial derivative with respect to x, then partial derivative with respect to y. So our aim is to reverse this back to the implicit equation that we differentiated to get this form. That is all about exact differential equation. So to proceed, what you are going to do is we have to prove that this equation is indeed an exact differential equation. And how do we do so? We always differentiate the partial derivative with respect to s. With respect to y, we differentiate here with respect to y, and we differentiate here with respect to x. Now let's differentiate here with respect to y. What are you going to get? With respect to y, the whole here will be 0 because there is no y term here. Then with respect to y, I'm going to get this place to be a constant, but here I'll get 4xy as my solution. Then with respect to x, this whole thing, there is no x content, so everything will be 0. Once I get everything to be 0, I'll come here with respect to x, I'm going to get 4xy. Since they are equal, I'm going to conclude that this equation is an exact differential equation. So let's proceed. Now what you're going to do is we take the term in which when you integrate, things will be easier and faster. So what you're going to do is I'm going to take this part. So I'm going to find the integral of ny dy, and that is integral of cos y plus 2x squared y dy. Now this is also the same as integral of cos y dy plus integral of 2x squared y dy. What is integral of cos y? That's going to give me sine y plus this. With respect to y, this becomes a constant, so I'm going to get x squared y squared because the 2 will cancel out these 2, then plus h of x is equal to c as my solution. So right now my aim is to find h of x here. To find h of x, I'm going to differentiate this whole thing with respect to x, then I'll equate to the partial derivative with respect to x here. So differentiating this whole expression, I'm going to get cos y plus 2xy squared, then plus h prime, differentiate with respect to x, this place becomes 0, so this place will be 0, so 2xy squared plus h prime of x is equal to 0. So I'm having 2xy squared plus h prime of x is equal to 0. When I compare this to this part, I can see that my h prime of x is equal to e to the power 4x. So once I get this, I just integrate both sides to get my h of x to be equal to integral of e to the power 4x. So what do I get? You know that integral of this, making our substitution u to be equal to 4x, is u over the x to be equal to 4. I'm going to have my, here the x is here, I'm going to have my x to be equal to 1 over 4 du. So I'll be getting 1 over 4 integral of e to the power u du. So my solution will be 1 over 4 e to the power 4x. So that is going to give me the solution for h of x. So my final answer is going to be sine y plus x squared y squared plus 1 over 4 g to the power 4x is equal to 0. So it's equal to c. Is equal to c as the solution for my differential equation. Thank you for watching. Kindly subscribe and also like.